Okay, on event 37, we're going to perform the test first at 300 kilometers an hour. Confirm, logger and exciter off.
Confirm, logger and exciter off.
So certification standards are developed over time. So as people learn how to fly, they understand what was caused the aircraft to be safe. And in many occasions, certification standards was written after accidents and in many occasions fatal accidents. So the old wording is certification standards are written in blood, which is sad, but on the other hand, it helps us to define a certification standard which we can use and to produce an aircraft that is quite safe. Now, firstly, we use the standard to design the aircraft safely, and once we completed the design, we go into this testing phase. And the testing phase, we now show, first for ourselves, that we do have a safe aircraft, but in the second hand, that we show compliance with the certification to obtain the type certificate. So in the flight testing area, there's a lot of tests that must be done. We have to show compliance with certain specifications, with other words, for example, stall speeds. We need to make certain stall speed, climb performances, descent performances. Then there's a lot of handling tests, so we have to show that the aircraft handles and the prediction on the handling is quite good. So you have to have positive response from the aircraft to define that a typical pilot will have no difficulties to fly the aircraft. And then there's also what we call the more destructive testing, which is the high-speed testing and spin testing. One of the areas where we expand the envelope, which is quite stressful, is the spin component of it. So we normally start with the aircraft in a very known condition. So very much forward center of gravity position, where we evaluate the first spins, and then slowly we advance the center of gravity afterwards to a point where we see that the aircraft first starts spinning very nicely, and then to a point where it starts to spin very stable. Now when the spins become stable, you know you're near the end of the envelope where it becomes dangerous to recover. Spinning is then also done in all the configurations, all the weight configurations, and with the envelope way far to the aft, and then in all the flap settings and air brakes and landing gear open and extended phases. So it is a quite intense, busy program with a lot of combinations of spins that needs to be demonstrated. During the high-speed flight test, we have to show compliance to the Flutter requirements, and we have to show that the aircraft is free in the complete design envelope up to the speeds VD in our case. Now we also start fairly slowly, and we have various methods where we introduce external disturbance either by pilot or by external components, and then we have to show that the aircraft damps this disturbance and becomes stable again. And at a certain speed, guys, any aircraft will flutter. You just have to give the speed high enough. At a certain point, you will get flutter. And our job is to show that within our design envelope, we are flutter free.
Event 7, 300 kilometers per hour. Accelerating now.
Check both switches off.
Affirm, both switches are currently off. Will be event 7, I'll switch on once established 300.
To grasp Flutter, there are some concepts that you have to understand. One is that the glider is an elastic object. It's not perfectly stiff, it can deform. While the glider is flying, it assumes a static or an average state. The wings will be slightly bent up typically, but turbulence will disturb the aircraft and it will deform away from its static state. So when the aircraft is standing on the ground, the damping will always result in oscillations dying out. But when the aircraft is flying, it's possible to extract energy from the airflow, and then the oscillations can either die out, which we want, or it can grow and will cause flutter. You start the flight testing procedure at a speed where you are confident that the aircraft will not flutter. And then at that speed you excite the structure, either through turbulence or inputs from the pilot, or using an excitation device attached to the aircraft. While exciting the aircraft, you have to measure the response of the structure. We use accelerometers, basically the same as in the GVT. For the JS2, we did not detect any tendency to flutter, and we are quite satisfied that it is safe up to the dive speed.
Okay, accelerating now to 300.
337.
So during the Flutter tests, you climb to an altitude of 15 to 16,000 feet. Then you start accelerating the plane. We first chose VNE, 270 kilometers per hour. We started with pilot input, so there's different ways. You first give a spike input, and then you go through a frequency sweep. So you start exciting the plane on all different axes. So you do it on the elevator, ailerons, the flaps, as well as the rudder. The plane didn't have any flutter tendencies at VNE, so we tested it at 20 kilometers per hour faster, at 290 kilometers per hour. Exact same results, instant damping, no flutter whatsoever. We then went up to 300 kilometers per hour, repeated the test again. The maximum speeds we've achieved with the aircraft were about 350 kilometers per hour, and still no tendencies to flutter. During the spin testing, it's pretty much a similar starting point than high-speed tests. You start at about 14 to 12,000 feet, depending on your altitude. I'm unsure, I think we did about 30 to 40 different spin tests. So we spun it in all possible configurations. The plane recovered pretty much immediately. The longest it took was with aft limit plus 10 millimeters, asymmetric. It took one turn to recover, which is well within the limitations. The recovery is super easy and straightforward. Exactly like every textbook says, you just neutralize all the controls, opposite rudder, stick slightly forward, and it automatically recovers. During the 5-turn spin, we actually saw that the airplane becomes quite stable, and after about 2.5 to 3 turns, the spinning ratio slows down significantly, and after 5 turns it recovered pretty much within a quarter turn by itself. I'm sure if we would have let it spin for another turn, it would have automatically recovered, which is very desirable and good behavior of an aircraft.